Hello everyone. Today we are going to discuss the equilibrium numerical. The first numerical is this one. Determine the reaction at all the point of contact for the sphere of 200 Newton kept in a trough as shown in figure. Now here this sphere is having the weight 200 Newton which is kept like this in this position by these two inclined plane. These two inclined plane having the angle with 35 degree and second is having the 60 degree with horizontal. Okay, now we want to find out the reaction at all point of contact, means at this point and at this point. Okay, so let these 2 points are A and B, and first of all draw the FBD of this sphere. Okay, now FBD of sphere means what? Imagine this body in the space. Okay, remove this contact and show all the internal and external forces and reaction at the point of contact. Okay, now draw this FBD of this sphere like this. At this point, suppose this point is A point. Here the contact is smooth, so reaction is perpendicular to the surface and A point, so that's why reaction is RA. Okay, reaction at the point A. Then at this point suppose B point, contact point B, this reaction, this surface is smooth, so reaction is always here, also here perpendicular to the surface at point B. Now reaction B is this point is B, so reaction is RB. Now we want to find out the reactions RB angle with horizontal and RA angle with horizontal. Now if this angle, this reaction having the angle with this surface is 90 degree. So if we imagine this is a right angle triangle, one angle is 90 degree, another angle is 60 degree, that is given in the numerical, and this angle we can find out because in the triangle the angle sum is 180. All these angles, if we add all these angles, so out of that one is 90, other is 60, so this must be 30. Similarly, here we can find out the angle of RB with horizontal 35. This angle is 90 degree. So remaining we can find out addition of this 2 and subtract addition of this 2 from 180. Okay, so we get that angle 55 with horizontal. Now the reaction is this one, RA 30 degree, and this is the 55 RB 55 degree. Now show, this is the FBD of this sphere. Now show all this reaction away from this joint. Okay, now the sphere, for the sphere all these forces are meeting at the point, that means all the forces are concurrent. Now all these forces, here count the number of forces, 1 2 3, 3 forces and 3 forces in equilibrium. Okay, first of all count the number of forces. We already know that equilibrium under 2 force, equilibrium under 3 force, equilibrium under 4 and more forces. So first of all count the number of forces on that FBD. Now here 1 2 3 forces. Now 3 forces meeting at a point means concurrent hai. So draw these 3. For the 3 forces we have the 2 theories. That 2 theories means these forces must be concurrent or either parallel. Okay, और either this must be concurrent or parallel. तो यहाँ पे parallel तो दिख नहीं रहे, so these forces must be concurrent for this sphere. So we can here, and also if the forces are concurrent, then we can apply the Lamè's theorem. So for that Lamè's theorem, we have to find out all these forces, draw all these forces away from the joint, means this is the force from second quadrant, this force is from the first quadrant, and this is the downward force, and draw and find out the angle between that each other. Okay, like this. So this is the second quadrant force which is having the 55 degree with horizontal. Then this is the RA is the first quadrant force which is having 30 degree, and also find out the angle between that these forces, between these forces, to apply the Lamè's theorem. Okay, so these are the angles we can easily find out with the help of geometry. This is the 90 angle. Okay, 90 plus 30 120, 90 plus 55 145, and remaining is must be 95. That 360, total is the 360 minus addition of this 2, or 180 minus addition of this 2, minus from 180. So we'll get this angle, same angle. Okay, now apply the Lamis theorem. For that Lamis theorem, we have the forces and we want to find out that RA and RB contact reaction. Okay, so this force divided by sine of this angle, this RB divided sine of 120 and 200 divided by sine of 95. So write down that equation by Lamis theorem. Okay, so this equation कहाँ से आई है हमें equation by Lamis theorem. So write down here. So by Lamis theorem we get this equation. Now we want to find out the RA and RB. So here if we equate these two, RA and RB, we can't get that RA and RB because both are unknown. Okay, so equate like this RA and this 200 upon sine 95. Here only RA is unknown. So by equating that we get the RA, and by equating first and last we can get the RB. So by equating first these two equation, so they multiply, cross multiplication, sine 145 numerator में चला जाएगा. So we get the simplified that and we get the RA 115.153 Newton. Okay, that is the answer. Again for the calculation of RB, equating these two. Okay, and here also cross multiply that and simplify that. By simplifying we get the value of RB, which is the value of contact reaction at A and B. So this is the answer. So simply first of all draw the FBD, count the number of forces and apply that conditions of equilibrium according to theory. Equilibrium under 2 forces, 3 forces, 4 and more forces, like that. Okay, now second numerical. A sphere weighing 1000 Newton is placed in a bench as shown in figure. Find the reaction at point of contact. Again here same, हमें point of contact पे ही reaction find out करना है. So here this sphere that is resting against this vertical surface and inclined surface, which is having angle 45 with horizontal. Okay, now first of all follow that same step, draw the FBD of the sphere and imagine that sphere is in a space and show all the forces, internal as well as external, contact reaction, weight, okay, all the forces on that, and count the number of forces again. Now here sphere FBD, first this surface is vertical, so reaction, suppose this point is A, so reaction is horizontal and RA is the reaction. Okay, this surface is a vertical surface, that's why this reaction is horizontal, perpendicular to the surface, arrow is towards the surface. Similarly, suppose this point is B, this is the inclined surface, reaction is perpendicular to this surface, like this is the 90-degree angle perpendicular to this surface, but this reaction is inclined and having the angle with horizontal, some angle with horizontal. So this is the 90-degree, this is 45-degree, and this must be addition, subtract this 180 minus addition of these two angles, we get the reactions, resultant reaction at B with horizontal, okay, angle. So we can get that 45 angle. So again 1, 2, 3 forces, this is in equilibrium, so 3 forces under equilibrium and these forces are concurrent. So apply the again same thing, Lamis theorem, we can apply that. Also we can here apply the equation summation fx0 summation fy0. Also we can get the value of this RA and R1 and R2, like this, okay, or RA and RB value. So here by applying simply Lamis theorem, all these forces are away from the joint. Okay, this is the second quadrant force, this is the right side, okay, lies on the x-axis, R1 or RA. So and find out the angle between that forces, like this. Now apply the Lamis theorem. So R1 divided by this 135 sine of 135, R2 or RB divided by sine 90, and 1000 divided by sine of 135. So this is the equation. Now we want to find out the RA, R1 and R2, means RA and RB. So by equating first this we will get the R1, by equating this two we will get the R2. Okay, so by equating this two equation, again do the cross multiplication, simplify that, we get that RA R1 means RA, that is equal to 1000. Okay, 135 sine 135 get cancelled, directly we get the 1000 Newton. Then similarly, by equating these two, cross multiplication, sine 90 into 1000 divided by sine 135 is equal to R2 or RB. So we will get that RB is this one. So these are the answers of the given question. Okay, contact reaction at A and B. Okay, these are the very simple numerical. Now next numerical. Two identical rollers, each of weight 700 Newton, are supported by an inclined plane and a vertical wall as shown in the figure. Find reactions exerted by supported by wall and inclined plane at C, D and E point. Means here these A and B are the two identical spheres. That weight of the two spheres are 700, that is given in the numerical. Also we want to find out that the reaction support reactions at inclined plane C, D and E point. Okay, contact reaction. Now again same thing here, draw the FBD. Now here these are the two objects. So draw FBD of A point, A sphere and B sphere separately. Now at the A sphere, these two are the identical sphere, but contact are the different. At C point, this is the vertical surface, this is inclined surface which is having angle 30 degree. Now at A sphere, contact C at the C point, at D point and between the two spheres. Similarly here contact for the calculate the contact for B sphere and between the two sphere and at the point E. So draw the FBD of two spheres separately. Okay, now here separate FBD. Here B point, B sphere, reaction for this between these two sphere is RAB. Okay, reaction at AB, contact reaction, and this contact reaction is towards the, for the B sphere, towards the surface. Now angle is 30 degree. How it is 30 degree? Suppose if we join the center of the A and B, this line, red line, is parallel to this inclined plane because these two are the identical sphere. Okay, क्यों है ऐसा? क्योंकि ये दो identical sphere है, इसलिए ये line parallel to this plane and this plane having the angle 30 degree with horizontal. That's why this AB line having the angle 30 degree with horizontal, and this reaction RAB is along this line AB. Okay, so that's why this reaction is also having the angle 30 degree. Now for this A sphere, this RAB is towards the point, towards the sphere A and having the same angle 30 degree with horizontal. Then for this B sphere, weight of this sphere, and at this point E, one inclined reaction, that is reaction is perpendicular at the point E but inclined for this horizontal, and that angle is, this is 90 degree, 30 degree, so this must be 60 degree, that is reaction at point B, E. Then for A, the FBD, weight of that sphere 700 Newton, vertically downward. Then this reaction RAB वो already हमने draw कर ली है, उसका angle भी हमने find out कर लिया. Then at C point is a vertical surface, that's why reaction is perpendicular to the surface and that's why it is horizontal. Okay, so towards that sphere. Okay, reaction arrow is toward that sphere. Then at D point, this reaction is perpendicular to D point or this surface. Okay, 90 degree reaction, RD is the reaction and arrow is towards that point D, 90, 30. So this reaction having the angle with horizontal is 60 degree. Now these are the, that is the FBD of this two sphere. Now solve one by one. So first of all, if we calculate that, okay, number of forces here 1, 2, 3. So 3 forces in equilibrium. So that we can apply the Lamè's theorem for this B sphere. And for A, count the number of forces 1, 2, 3, 4 forces. 4 forces, concurrent forces. So summation Fx, summation Fy equal to 0. So we can solve by that. Again here for the, if we take the FBD of A sphere first, so calculate the unknown first RAB, second RC, and third RD. So we have the only two equations, summation fx0, summation fy0, and unknowns are 3 unknown. So we can't solve that this two equation by 3 unknown, sorry, 3 unknown by 2 equation. So first of all, solve the FBD of this B sphere, then find out this reaction RA, put that value for this sphere A FBD, then unknowns are reduced to only 2 unknown. Then we can solve this FBD of A. So first of all, solve the FBD of this sphere B. Now this is the second quadrant force, this is the first quadrant force. So draw all this away from the joint and find out the angles between these forces. Okay, and apply the Lam's theorem. Likewise, this is 90 degree, 120 and 150. Now apply the Lam's theorem. So by Lam's theorem we get the equation RAB divided by sine 150, RE divided by 120 and 700 divided by 9 sine 90. So we get this equation. Now for RAB equate these two, and for the RE equate these two. We get that unknown value of this RAB, and by equating these two we get the value of RE. Now put this RAB value in for the sphere A and find out the remaining unknown. Now for for the sphere A, RAB is this one, having the same value, opposite in direction, angle must be same. Now for this sphere A, 4 concurrent forces are there. Okay, concurrent forces condition is summation fx0, summation fy0. Now apply these two equation one by one. Now first of all, summation fy0. Okay, if we apply summation fy, so this is minus 700. This vertical component of RD is, that is RD sine 60, and this vertical component of RAB downward minus RAB sine of 30 degree, like this. Okay, now RAB we have the value, put that value, simplify that equation. Unknown is only RD. Now by simplifying that we get this unknown RD equation's value. Okay, contact reaction at point D. Similarly apply the next equation, summation fx0, then x component of RD minus RD cos of 60, then this value minus RAB cos of 30 degree and plus RC. Here only RC is unknown because we have the value of RD and value of RAB. So put that both value in this equation. Unknown is only RC. So by simplifying that we get the value of RC. Okay, so likewise draw the, if there are the two object, okay, which are having the contact with each other, draw the FBD separately, count the number of forces, count the number of unknown, and likewise apply the conditions of equilibrium, two force equilibrium, 3 force equilibrium, and 4 and more forces equilibrium. Okay, now next numerical. A 30 kg pipe is supported at A by a system of 5 cords as shown in figure. Determine force in each cord for equilibrium. Now here this system is given. Okay, at point A 30 kg pipe is, the mass of that pipe is given, 30 kg is attached at point A. Now find out determine the forces in each cord. We want to find out the force in this AB, BD and BC. Force in this cords. Because of this mass, the force is developed in this cord by this arrangement. Okay, so if we consider the point A and point B, so by this only FBD of, if we draw the FBD of this point A and point B, now because of this mass or this weight, the tensions are developed in these cords. Okay, so in this cord tensions are developed, and we want to find out the tension at point for the that cord AE, AB, BD and ABC. So tension is always away from the joint, okay, away from that point. So if we consider the joint A, so tension in this AE is away from joint AE, A point. This in the AB away from this point. Again, if we consider the FBD of this B point, at B point the tension in the AB is away from the point, BD is away from the point, and BC is away from the point. So according to that, draw the FBD. And here also for this BD portion, for this chord BD, the angle is not given with horizontal, that slope is given, okay, vertical and horizontal. So find out that slope with horizontal, or find out the angle, okay, for the BD with horizontal. Now here this angle is, this is the vertical portion, we want to find out this angle, this must be equal to this angle, okay. So suppose this is a theta, so this theta, now in this triangle, right angle triangle, vertical theta's opposite side and theta's adjacent side is given, so we can apply the tan theta is equal to 3 divided by 4. If we get the tan inverse of this quantity, we get that angle 36.86. Now remember this 36.86, if we the calculation is 3 divided by 4, हमें रिपीट करने की ज़रूरत नहीं है, ये कैलकुलेशन याद रखो, ये हमेशा इसका एंगल 36.86 आता है अगर अपोजिट साइड 3 है और एंड एडजेसेंट साइड 4 है तो, ये स्टेप लिखना है, बट कैलकुलेट डायरेक्टली, राइट डाउन दैट थीटा इज इक्वल टू 36.86. तो यहाँ पे आपका टाइम बचेगा, ओके, वी कैन सेव टाइम लाइकवाइज. नाउ दिस एंगल फॉर दिस पॉइंट बी, ओके, सो दिस इज 36, दिस इज 60 डिग्री, सो ये भी 60 डिग्री होगा, सो दिस इज 60 डिग्री, ओके. फोर्सेस इन दिस chord अवे फ्रॉम द पॉइंट बी, ओके, बिकॉज ऑल दिस हैविंग द आर द टेंशंस in that chord. Similarly, at point A, if we draw the FBD, the AE tension is away from the point. This is the 30 kg is the mass given, so multiplied by 9.81, so we'll get the force, or we get the weight of that pipe, and tension in the AB is away from this point. Now draw the solve the FBD of this point A and B. Now which point we have to calculate the first? Suppose here B, if we take the FBD of B point, now unknowns are tension in the BD, tension in the AB, and tension in the BC. All these three are the unknowns, so we can't solve the three unknowns by this Lam's theorem, okay. So here if we consider the joint A FBD, here unknown tension AE, unknown tension AB, but this weight is known. So here three forces under equilibrium away from the joint, we can apply the Lam's theorem. So we can solve this and find out the tensions AB and AE. And here for this joint B, now if we get the tension AB from A joint, so this tensions value is must be same, okay. Then we can solve these two tensions. So solve the first A point FBD. Now for that A point FBD, find out the remaining angles between the forces and apply the Lam's theorem. Now Lam's theorem equation, tension AB is equal to, this angle is 90 degree, so sin 90. Tension AE is equal to, this is 90 plus 60, 150, so that sine of 150, and this force divided by this angle, okay, that is 120 degree. Now by equating these two and by equating these two, we get the tension AB and AE, okay. Calculate that, do the cross multiplication, simplified that, and we get the value of tension AB 339.83 Newton, first value. Second, by equating these two, again do the cross multiplication and simplify that, we get the value of AE, okay. Now we can have that tension AB, put this value tension AB for the FBD B at the B point. Now B point, this B tension AB, we have this value. Now we can calculate the remaining two by Lam's theorem, okay. Apply again Lam's theorem for the B point, okay. These angles, find out these angles and apply the Lam's theorem, okay. By applying Lam's theorem, here tension AB, we have the value, put this value here, then equate these two, we get the value first BD and then BC, likewise BC value, okay, by doing the cross multiplication, simplified that, again by equating these two remaining, okay, BC for the tension, to find out the tension BC, and we get the tension. So draw the FBD, then watch the number of forces, count that forces, and we can then apply the condition of equilibrium as per our knowledge. Okay, जैसे हमने सीखा है. Thank you.